Well, hello everyone. This is Chris back again. Just going to continue on our line of discussion about dissolving, and ultimately we're going to explain this concept of precipitation. So I just wanted to clear up any confusion over dissolving, and what I talked about in the first video was the basic concept, and I just wanted to draw this perhaps to a little better scale here. So here I have our water, our aqueous solution, and I have sodium chloride, a molecule of table salt, which is generally going to be a solid. Okay, I add that to the water, and as we learned in the first discussion, the water is a polar molecule. The oxygen takes on a partial negative charge because the oxygen is so electronegative that it kind of hoards the electrons, whereas the hydrogens take on a partial positive charge. Now, one thing that I didn't really emphasize in the last video was that the sodium and the chlorine are very large atoms. They have a large atomic radius compared to oxygen and hydrogen. Obviously, hydrogen is going to be one of the smallest, simply because it's one proton, one electron. There really isn't a whole lot of space there being occupied. The reason oxygen is rather small is because oxygen is so electronegative. It kind of pulls those electrons in, if you want to kind of look at it like that. So really, what happens is sodium and chlorine are pulled apart. And the way that they're dissolved, they're not actually, it's not a one molecule to one molecule kind of thing, one molecule, one ion of sodium to one molecule of water. What happens is it's multiple. So I just kind of drew the little circles here are oxygen, and the little hydrogens, of course, attached to them, single covalent bond. So these are individual water molecules. And what you can see is the sodium and the chlorine atoms are much larger. So you have several molecules of water basically surround these ions. So here you have the oxygen end of a water molecule being attracted to the sodium. So you have the oxygen end being attracted to the sodium, and that's actually what's keeping it dissolved. Whereas the chlorine, you have the hydrogen end being attracted to chlorine, and the oxygen end is, of course, out away from the chlorine because of the negative charge. And again, several molecules around there. So I just wanted to clear that up. All right, so we're good on dissolving, and we kind of have at least a mental picture and some intuition on how this works. So let's talk about the development of a precipitation, and I'll just go ahead and give you guys an example, and we'll kind of mill it around in our heads here. So what I'm going to do is I'm going to take some aqueous solution here. We're back in the chemistry lab, and we have our little beaker water, aqueous solution. And within that aqueous solution, I have, excuse me, I have potassium chloride dissolved in there. Okay. And potassium chloride is KCl. Okay, I've dissolved. It doesn't matter how much. We're not talking about moles. We're not talking about molarity, osmolality, none of that. I just have potassium chloride dissolved in here. So, potassium, chlorine. We know that just like sodium chloride, the potassium and chlorine is going to be pulled apart. Chlorine is going to be attracted to hydrogens. Potassium is going to be attracted to the oxygen of the water molecule, and that's actually what causes it to be dissolved in an aqueous solution. Okay. Now, outside of here, what I have is I have a solution of silver nitrate. Okay. AgNO3. This would be -1. So I have a positive 1 silver, and then a negative nitrate. So this is basically an ionic bond, an ionic molecule, silver nitrate. What I'm going to do is I'm going to introduce this sodium nitrate into here. Now this is a solid, this is an aqueous solution, and what do you suppose is going to happen? Well, what's going to happen is I introduce this into the solution, this silver and the nitrate are going to dissociate, but then something interesting is going to happen. Something very interesting. What's going to happen is the silver here is going to interact with the chlorine here. But it's going to interact in an interesting way. It's not interacting in that it's interacting with the water and being dissolved by the water. What's happening is there's actually going to be a bond occur. Okay, so the positive silver and the negative chlorine are going to be attracted, and they're going to bond together. Now remember, for something to be dissolved in water, it has to bond with the water molecules. They're not bond, but it has to be attracted to the water molecules. Now what's happening is the attraction between silver and chlorine is stronger than the attraction with the chlorine and the silver with the water molecule. So what do you suppose happens? Well, I make silver chloride in this water here. Okay? Well, this silver chloride is no longer dissolved in the water, and it becomes a solid. And more silver chloride is made, depending on the concentration and all that, but we don't even have to worry about the concentration as long as we understand the concept that these are solids developing within this liquid. And what do you suppose starts happening? Well, normally this solution, potassium chloride solution, is normally clear. Well, what's going to happen is I'm going to start getting some precipitation, almost looks like little crystals developing in there. It's going to kind of get white, and there's going to be, this solid precipitation that develops is probably going to sink to the bottom. And it's because of that interaction between the chlorine and the silver. It actually interacts, becomes a solid molecule in the water. It's no longer dissolved in the water. It becomes a solid, and it falls out of the solution as a precipitate. And that is the basic chemistry behind a precipitation reaction. So going back to the gentleman who asked me about medications and drugs and so on precipitating, that is the chemistry behind what occurs. Obviously, it's going to be different atoms involved, different ions involved with different medications, but the underlying chemistry is exactly the same. All right, guys, hopefully that you found that interesting and somewhat intuitive. Thanks again. Bye-bye.